Today I'm going to introduce Anthony, and me and Anthony worked over the summer on a very exciting project looking at changes in extreme precipitation in the western US. And we did so much work that Anthony actually was able to work on two different projects, like two posters. And today, Anthony will give you kind of an overview of our major findings in this very, very interesting research. So I'm going to let Anthony do the rest of the talking.
Okay, take it away.
Okay, so hello, my name is Anthony Mao, and today I'm going to be talking about the extreme rainfall climatology of the Western US, and my mentor was Professor Ayala. So first, I want to get into what is extreme climatology. So extreme climatology is when weather or climate conditions like temperature, precipitation are very severe or unusual. And it's important to study extreme climatology so that we are better prepared to adapt to it in the future. You can see this image here. This is a wildfire. This is lightning. This is a tornado. This is a hurricane. And this one on the right is like a flash flood. I'm sure we have all experienced more extreme weather across the globe recently, like hurricanes, wildfires, and floods. One example of a hurricane I saw was Hurricane Ida in the eastern US. And one example of a wildfire I saw was the Caldor fire in the western US. And all of these events can have disastrous consequences for both people and wildlife. Here's just some images of each. So for my data, I used 16 weather stations in the Western USA. The map shows where exactly those stations are. I analyzed 60 years of daily rainfall data from NOAA Environmental Center from 1960 to 2020. I also analyzed 60 years seasonal average of temperature and precipitation data from Giovanni. And for the future years, 2030, 2070, and 2100, I looked at precipitation and temperature data from 4 emission scenarios, with 2.6 being the lowest emission scenario, meaning if we took action to reduce emissions, followed by 4.5, 6.0, and 8.5 being the highest emission scenario, meaning if we were to just keep polluting. This data was from the GIS Climate Change UCAR. So I first used the R function to add the daily rainfall data for all missing dates to each weather station. Then I extracted 4 percentiles for all stations, with 10 being the lowest, followed by 90th, 95th, and then 99 being the highest percentile. That's like how many days were at or above 99 extreme precipitation as extreme precipitation. I did a man-Kendall test to see, is there any increase or decrease in the number of extreme precipitation days? I also used QGIS to create a map of the tau coefficient and the p-value for all 4 percentiles in each weather station. I downloaded 2 correlation maps from Giovanni. One was temperature and precipitation, another was water vapor and precipitation. Finally, I used QGIS to produce a map of each data. One was precipitation, each year for all RCP scenarios, the 2.6, 4.5, 6.0, and 8.5. And temperature, again, same thing, each year for all 4 RCP emission scenarios. And I found that overall, from 1960 to 2020, most weather stations in the Western USA experienced an increase in the number of extreme precipitation days, like Aberdeen as shown in the plot with red dots. This point right here I'm pointing to, for example, means that in the year like 1999, there were 9 days that were above the 99th extreme precipitation number. A few weather stations in Western USA experienced a decrease in the number of extreme precipitation days, like Alpine as shown in the plot with orange dots. And here are 2 of the maps I use. I had more, but I only have time for 2. The one on the left shows the tau values for the 95th percentile trend. And the stations in the red had more extreme precipitation days compared to the stations in the blue. And the one on the right shows the p-values for the 95th percentile trend. And the stations in the red, their extreme precipitation days were very significant, while the stations in the blue, their extreme precipitation days were not so significant, so about the same. I also found that in the past 40 years, there is a negative correlation between temperature and precipitation for the Western USA. As the temperature increased, precipitation decreased, and the same way around, as the temperature decreased, precipitation increased. The map on the left below shows the negative correlation between temperature and precipitation. And the map on the right, there is not much correlation I found between water vapor and precipitation. So in the year 2100, under the 8.5 or the highest emission scenario, California, Arizona, and parts of Nevada will receive less precipitation compared to the year 2030. So they will become drier. Also in 2100, Washington, Oregon, and Idaho will get more precipitation compared to 2030. So they will become wetter. And here are 4 RCP maps I used for precipitation. In 2030, 2.6 and 8.5, and then in 2100, 70 years later, lowest and highest emission scenario. And these are some maps for temperature. I could only do the lowest 4.5 emission scenario for 2030 and 8.5, and same for 2100. And to summarize, California, Nevada, and Arizona are expected to become hotter throughout the next few decades. Washington, Oregon, and Idaho are expected to get wetter in the next few decades. And finally, extreme precipitation and variability is going to become more common in the Western USA. This map down here shows like there's some red spots in California, so that's generally much hotter compared to Washington, where it's more cool and mild. And the map on the right shows the amount of precipitation. The blue here does not mean more precipitation. That just means less, so it will be drier. And the red and yellow is like a little wetter. That's it.
Well, I don't think anyone is going to be able to argue with your conclusions based on what we've just been living through for the past couple months. But this was really a great amount of data analysis. So let's all give Anthony a round of applause.